All right, so here we're supposed to solve this linear programming problem again using the table method. So first things first, we have to convert this inequality method, the I system, to the E system. All right, so that means we're going to add slack variables. And this time we have two inequalities we have to convert to. So that's going to give us x1 plus 3x2 plus s1, and that's equal to 18. And then we have here 5x1 plus 4x2 plus s2 is equal to 35, and x1 and x2 are still greater than or equal to 0. All right, so now let's see if we can get this whole table on here. So we have x1, x2, S1, S2, and we're wanting to maximize P, so we'll put a P column as well. And so let's kind of put rows. So we have one, two, three, four, five, six. I think there's going to be six rows because we have that many columns. So it's going to be a zero, 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 zero. And then now we move over. So it'll be zero, zero, and then zero, zero, and then we'll have zero, zero. Okay, so we put all the zeros in first, and then after that we start plugging in our values to figure out what we get for our S1 and S2. So if X1 and X2 are 0, S1 has to be 18. And if X1 and X2 here are 0, S2 has to be 35. And if we do this, we can also kind of come over here. So P is going to be equal to what? Well, it's going to be 40 times 0 plus 50 times 0, which is 0. Okay, so that gives us 0. All right, now we have x1 is 0, s1 is 0. So x1 is 0, s1 is 0. So 3x2 is equal to 18. So x2 has to be 6. And so if this is 0, this is 6, so that's 24. So we subtract 24 over here. That's going to give us 11 for S2. And so P is going to give us what? Well, it's 40 times 0 plus, looks like 50 times 6. So that's going to give us 300. Okay, so that works. Now here we have x1 is 0 and s2 is 0. So that's 0, that's 0. So 4x2 is 35. So that's going to be 35 divided by 4. Okay. And so then we plug in the other one. And I think we've already done this one here, if I remember right. All of a sudden, this is seeming very, very similar to one back here. This one, yeah. So we have the same number. So that's going to be negative 33 over 11, or 33 over 4, sorry. So negative 33 over 4. And oh, did we put that? Didn't put 300 here. Now this one has a negative. So this one is not a feasible solution. So we're done. Now, instead of calculating all these, let's go back and get those numbers. So that's 18 and negative 55. So that's 18 and negative 55. And so again, we just plug those in up there and we get that. Well, guess what? That's not feasible either. So if we go back, that next one was 7, 11, and then 3 and 5. All right, so we'll just type those in here or write them in. 7 and 11, and then 3 and 5. Okay, so now we actually have to calculate those. So 5 is going to be P is equal to, and then we have our, what is it? 40 times 3 plus 50 times 5. And so that's going to give us P is going to be 120, 250. Let's wait. 3. Oh, wait. I'm doing the wrong one. 5 is 7 and 0. I'm looking at 3 and 5. So this is 6. We'll do 6 first since I looked at the wrong one. And so that's going to be 370. So that's the bottom one. And now let's do 5. So P is equal to 40 times 7 plus 50 times 0. And that's going to be what? 280. And so that's 280. All right. So if you put them in the right order, you get them the right numbers. But anyway, we still get the right values at the end. And so we're supposed to maximize P. So the highest one happens to be, it looks like 370. Okay. So then we can say the max P is equal to 370 at, and it looks like x1 is equal to 3 and x2 is equal to 5. And so that would be our overall solution to this using the table method. Okay. All right, so let's stop with that and then we'll come back for one more. And again, it's a long one, so we'll just do it only by itself.